Hi, this is Dominique Galvez, and welcome to the Getting Started Guide Part 1 for Ansys CMAX OpticStudio. In this video, we will introduce you to OpticStudio, what it does, and how to navigate your way around the program. So first of all, what is OpticStudio? Ansys CMAX OpticStudio is an optical design software tool used by companies and universities around the world to conceive of optical designs for imaging, illumination, laser systems, and more. OpticStudio does this by using a powerful ray tracing algorithm to design and analyze optical systems. It enables the setup of optical designs, analysis of its performance, optimization for improved systems, tolerance analysis for evaluating manufacturing defects, and more. In this series of videos, we will discuss OpticStudio's sequential mode. In sequential mode, OpticStudio traces the rays through a predetermined sequence of surfaces, originating from the object plane until they reach the image plane. This mode is most useful for imaging and afocal systems. In comparison to sequential mode, OpticStudio also features a non-sequential mode, which will not be covered in this series of videos. Before we dive into what OpticStudio does in sequential mode, let's go over a few basic first-order optical concepts that will help us to understand the basis of OpticStudio's sequential calculations. In this lesson, you don't need to understand all the math, but it's helpful to know what assumptions are being made during the simulation that may affect you and your system. In OpticStudio, the propagation of light is modeled primarily with a geometric ray-based approach, which means using Snell's law, as shown here. However, many optical properties are derived from reforming this equation with the power series expansion and looking at the first-order term only. We call this the paraxial approximation. The paraxial approximation may be used to find the pupils of the system. So, let's discuss stops and pupils. All optical systems are limited in aperture by one or more components, but the aperture that most limits the on-axis bundle of rays is called the stop surface, or the aperture stop. This is a real physical object in your system, like a lens mount or iris aperture. Then, there are two accompanying concepts to the stop, the exit pupil and the entrance pupil. The pupils are images of the stop when propagated forward into the image space or backward into the object space, respectively. The exit pupil may be easiest to understand at first, since it is just the image of the stop when propagated through the optics between the stop and the image plane, while the entrance pupil is the image of the stop when back-propagated through the optics between the stop and the object plane. If there are no optics between the stop and the object plane, then the stop is also the entrance pupil. If there are no optics between the stop and the image plane, the stop is also the exit pupil. The entrance and exit pupils define the cones of light entering and exiting the optical system, essentially defining how much and at what angles light is accepted into the system. In paraxial optics, two specific rays can define and characterize an optical system, the marginal ray and the chief ray. The marginal ray starts at the base of the object on the optical axis and fills the edges of the pupils and stop. Where it crosses the optical axis determines where the image planes are. Therefore, the marginal ray can determine the effective focal length, f number, as well as the pupil size. The chief ray starts at the top of the object and crosses through the center of the pupils and stop. Where it crosses the optical axis determines the pupil planes, and it determines the field of view and image height. As a quick aside, it is important to know that OpticStudio uses normalized field and pupil coordinates. This means that independent of a field or pupil size, each is treated as a coordinate system with a maximum radial value of 1. This normalization makes it easier to reference the field or aperture point you want to consider, independent of the actual size of the field or aperture. In sequential mode, the ray begins at some point on the object defined by normalized field coordinates hx and hy. It then propagates through the system to the normalized pupil coordinate px and py before propagating through the rest of the system. With that out of the way, we're ready to explore OpticStudio. These concepts will be used frequently when defining the properties of our optical systems. So, let's start with a quick tour around OpticStudio. There are 5 key areas of the user interface. First, I'll point out the ribbon bar, which is clustered into task-oriented tabs. Each of these tabs contains groups of function icons. As an example, I can select the Setup tab from the ribbon bar and see that it's divided into groups like the Editors group, Systems Viewers group, etc. At the top, there is the user-definable toolbar, which by default contains common functions like new, open, save, and so on. The functions on this toolbar can be configured in the Setup tab, OpticStudio Preferences, and then the Toolbar tab. But next is the System Explorer on the left. The System Explorer contains the system-specific information about the optical system being designed. It's for system data that is usually set once at the beginning of your design and left alone after that. Then, the workspace. It is generally where you'll be working on your design. If you pick up and drag your workspace windows, you can use the crosshair to dock the windows into convenient orientations. Lastly, there is the status bar at the bottom of the program, which displays useful information about the current design. You can customize what information is displayed here by going to the Setup tab, then the OpticStudio Preferences, the General tab, and the Status Bar section. So, while we're in the ribbon bar tabs now, let's discuss each one. The File tab has your typical file input and output functions, like opening or saving files, split into these groups. Here, you can import your lenses or export them into various file formats. The Setup tab is used when you start a project and is used infrequently, if at all, after the initial setup. Note the System Check button, a diagnostic feature that summarizes any warnings or error in the system. It can serve as a good starting point for troubleshooting in OpticStudio. In the Analyze tab, you can find your system's detailed performance data over a wide range of metrics. The analysis features never change your design, but they provide the diagnostic information that will help guide any required changes. Then, the Optimize tab is where you'll find the tools and features to make the changes that will improve your system according to your specifications. We'll use the Optimize tab to optimize a singlet in the next video in this series. The Tolerance tab is where you can control the tolerancing capabilities. It allows you to see the effect of finite manufacturing and assembly tolerances on the design. We'll cover the capabilities of a Tolerance tab a bit more in another video. Next, the Libraries tab is where you'll find all the catalog data that ships with OpticStudio, like optical materials and stock lenses as provided by manufacturers, thin film coatings, light sources, design templates, and so on. In this tab, you can also define your own entry into one of these catalogs or upload files given to you by manufacturers. The Part Designer tab features a geometry creation tool where you can draw, extrude, revolve, or use Boolean objects to create CAD parts that can be used in the premium edition of OpticStudio. You may also import your own CAD models. Although OpticStudio has a large range of features and analysis tools, the Programming tab provides programming capabilities that allow for customization and automation of existing calculations. These tools make it easy to implement specialized calculations, display data in specific ways, or automate repetitive keyboard tasks. Then, in some versions of OpticStudio, you'll have the Star tab, which includes tools to incorporate structural and thermal analysis on your system. But it's outside of the scope of this video series. Finally, we have the Help tab, which provides links to various resources. I'll point out the Help System tool specifically, which has its icon here, but it actually has icons all throughout OpticStudio. The reason for this is that each icon will open a new instance of the Help system, opened specifically to the relevant passage for wherever you ask for help. For example, in the workspace, there is the Lens Data Editor window. If I click on the Help button in the Lens Data Editor, the Help system opens to the page about it, where I can find more information or scroll down to find more links to explore within the topic. Within the Help system, you will find detailed descriptions for all the tools and options in OpticStudio. You can even use the Search tool here to find all the instances of any specific keyword you want to investigate. Back in the Help tab, you can access free tutorials, articles, and videos that are useful when learning or refreshing yourself on OpticStudio. There are also community forums, where users can post questions or discuss with others who use OpticStudio. Lastly, I'll mention that many windows in OpticStudio feature a toolbar with functions useful to that window type. We will cover one type of toolbar later in this video. So, with the tour done, let's set up our own lens system file. When you open a new OpticStudio file, the program should look like this, and if it doesn't, create a new blank file with the New button on the top toolbar. Alternatively, your file could be in non-sequential mode. In the Setup tab, you can select which mode you would like to use. So select Sequential tab if that's not already done for you. For now, let's focus on the System Explorer window, since it is where we'll define the basic environmental inputs of our system once, and then leave it untouched as we design our system. If we click on the drop-down arrow of any of these options, you can see that we can edit these system properties. So let's start with our wavelengths. You can enter your desired wavelength directly in the System Explorer, or if you double-click the wavelengths header, you can open the wavelength data window, where you have more options. Here, you can manually enter your desired wavelength, or enable multiple wavelengths with these checkboxes. Lastly, you can use wavelength presets that are common to your application. For now, I'll stick with using 0.55 microns, the default wavelength for new OpticStudio files. Next, let's apply some field data points. You can edit the fields of your system from the System Explorer window, but it's easier to visualize in the Field Data Editor, so you can double-click to open it or press the Open Field Data Editor button. As a default, there is one row of data here, corresponding to one field, which enters the system along the optical axis at 0 degrees in X and Y. It is illustrated in the plot to the right by this green dot. Now let's say we want our system to have a field of view of plus or minus 10 degrees. With this field row selected, I can press the Insert key to add a new field row. We will be creating a basic system using lens types and orientations we know to be rotationally symmetric. So there's no need to tilt the field in both the X and Y or in both positive and negative directions. So let's make this second field enter the system at 10 degrees in Y. Alternatively, you can have OpticStudio populate the field data editor for you by using the Fields wizard. Here you can decide how you would like to distribute your field data points, and I'll select equal area Y fields for now and set my maximum field to 10 degrees. Then press OK. It's populated our on-axis field point, our maximum field point, and our equal area field point. While we're here, let's take a moment to remember from our discussion on normalized field coordinates that the maximum field defines the extent of the normalized field coordinates. You can see that here with the maximum field data point at the furthest extent of the field having an HY coordinate of 1. You can see the coordinates of the other field points or anywhere in the field coordinate by hovering over the space. Now before we move on, we should note that field of view can be defined in different ways, not just degrees. If we click on that Field Properties dialog box again and go to Field Type, you can see here that OpticStudio supports 5 types of fields. I'll briefly go over some of the use cases for these, but check out the Help button for full descriptions. So which field type should you use? Well, it depends on your application and what is known about your system. If your system has collimated incoming light, such as light arriving from an object effectively infinitely far away, use the angle to define your field of view. Or, let's say you're trying to image an object not at infinity, then you can enter your object height in millimeters instead. Or, what if you only know what height you need the image to be, like in the case of a known detector? You may want to use the paraxial or real image height, basically defining your system from the end state. Lastly, you can convert between field types if you'd prefer. In most cases, one field type can be translated into another field type, so it is up to the user's preference to determine which is appropriate. The main exception is that the object field type cannot be used for objects at infinity, like we have here. Our object is at infinity, and if I try to change our angles to object height, it'll throw an error. So let's close out our field data editor to look at the next of the main system properties, the aperture. Unlike the other two properties, aperture doesn't have its own dialog window, so we just edit it here in the System Explorer. We can see that there are 6 definitions of aperture supported. 3 are object space definitions, 2 are image space definitions, and 1 is defined by the physical aperture in the system. As with fields, any one type can usually be substituted for another type. For further descriptions of each type, click the Help button of the System Explorer and navigate to Aperture and Aperture Type. For now, I'm going to use the entrance pupil diameter for our aperture type, and I'll set it to 10 millimeters for example in a moment. But I want to point out that currently the semi-diameter or size of our surfaces is 0. But when I enter the 10mm entrance pupil diameter, OpticStudio will by default automatically update these so that the rays are not clipped off by elements in the system. So let's close the aperture dropdown, and you can see that the System Explorer allows you to define other fundamental properties of a system, like the expected environmental or lab conditions, polarization, and more. Essentially, this window is used to define global system settings, and we typically define these items first. With our fields, aperture, and wavelength defined, we're ready to start creating our system. Let's navigate over to the Lens Data Editor window, where we can see these 3 rows of data are created by default. Each of these rows represents a surface, a possible interface for light to reflect or refract on. The 3 default surfaces are the object, or the thing that we want to image, the stop, which defines the amount of light that will go through the system, and the image. The most important of these data columns for a beginner to understand are the radius, thickness, and material columns. Now would be a good time to note the sign convention in OpticStudio. OpticStudio uses a right-hand coordinate system, where z is the direction of propagation and is typically graphically shown as going from left to right. Positive thickness values, therefore, are in the direction of propagation, while negative values signify going against the propagation direction. Now, a surface's radius of curvature is given as the distance from the vertex to the center of curvature. So, if we wanted to make a biconvex lens, this surface would have a positive radius of curvature, and the second surface would have a negative radius of curvature. Lastly, the material column allows you to define which material exists after the surface interface. I'll pick NBK7, which is one of the default glasses from the Material Catalog in the Libraries tab. I can open the Material Catalog to the NBK7 entry by selecting the glass and pressing F4. Here, I can see the properties of the glass, like dispersion and any other information the manufacturer provides. Now, let's open a lens layout from the Analyze tab so we can see what we're doing as we build our system. We can insert more surfaces into our Lens Data Editor window by selecting a row and pressing Insert on our keyboard, or by right-clicking and pressing Insert Surface or Insert Surface after. Then I want to give our lens some thickness, let's say 5mm. Then we need to give it some radii. Let's do 50mm and -50mm. Now we don't see anything changing in the 3D layout window here, and that's because we need to go to the Settings tab in the Layout toolbar and tell it what surfaces we want it to draw. Since the object is at infinity, we won't be able to draw it, so I'll select Surface 1, and I want to see all the way to the image plane, which is our Surface 3. Now we can see that we've successfully created this lens shape here, with defined radii of curvature, a defined thickness, and a material. You can see that there are plenty of other columns here that we won't get to today, but they allow you to control the optical or mechanical diameters of your system, or even use a conic constant to make your surface aspheric. OpticStudio actually has even more options if you open the Surface Properties dialog box by clicking on the word or the arrow here. You can also change which surface you're looking at by using the left and right arrows here. In the dialog box, you have all of these option tabs. Within Type, you can change the type of surface, from standard to many more, like even or odd A-spheres, Zernike coefficient-defined surfaces, or even user-defined surfaces. OpticStudio allows you to be very flexible with your surface types. Look to the help guide for descriptions of each surface type and the equations that characterize them. In the Draw options, you can control how this surface is drawn in the lens layouts. Otherwise, you can set a specific aperture within this surface, change the scattering properties, or add coatings, all within this dialog box. Click the Help button here for specific information about the options in the Surface Properties dialog box. Now, as I mentioned before, I'll go over the toolbar specific to a common type of window, the System Viewers and Analysis windows, which function pretty similar to each other. So we have our 3D layout already open, but let's open a common analysis window, the standard spot diagram. Then I'll dock it here. So notice how you can rotate around the 3D environments with intuitive mouse controls, clicking and dragging around. To return to a default view rotation, use the Camera View drop-down button. To zoom in on the layout or analysis windows, you can use the scroll wheel, or the zoom tool, where you can click and drag to zoom into a specified location. You can then use the Reset Zoom button we used earlier to show all the active surfaces or data. Also in these toolbars, you can see that you have annotation tools for you to mark up the plots with shape, arrows, or text before printing, saving, or copying the information. Lastly, the tab at the bottom of the analysis windows gives you the option to switch from this graphical representation to a text-based view of the data. Some text tabs have a full set of raw data, while others have a text summary. In these windows, you can use the Settings drop-down arrow or click on the word Settings to open up the Settings dialog box, where you will find the settings options appropriate to this window's data. It's important to note that you can select your settings and then press Save. If you do so, it will save these settings and implement them in all future files. You can press Reset button to restore to factory defaults. And with that, we've completed our tour and basic data input tutorial. In this video, we have provided a brief introduction to OpticStudio, including the basic principles it relies on, how it calculates results, and how to navigate through the many windows of the user interface. Check out the next video in the series to continue learning how to use OpticStudio. Thanks for watching!